This set of notes are for week 8 and covers section 4.3 from your textbook. Before the break, we talked about sections 4.1 and 4.2. Let's review. Chapter 4 deals with procedural abstraction. C++ refers to their subprograms as functions. We will be learning how to use pre-written functions, write our own functions, and build programs that are more robust by using functions. The first two topics we talked about prior to the break. We'll review them quickly. The focus of these notes is section 4.3, Programmer-Defined Functions. The strategy we want to use when we build our programs is a structured approach that uses top-down design. Top-down design allows us to refine our algorithm by breaking it into subtasks. We break it into smaller and smaller pieces until each piece is a trivial amount of code to implement. Then we can put those pieces together to form the program. The advantages are many. The code will be easier to understand, easier to change, easier to write, although I know it doesn't feel that way at first, easier to test and debug, and this is a way that teams of programmers can work together. Predefined functions. There are many of predefined functions in the C++ libraries. Remember our use of the random number generator from the C standard lib? Section 4.3 is the focus of these narrated notes. We're interested in writing our own functions. Now, remember, we think of a program in terms of an IPO chart, input, process, and output. Each one of our subtasks or functions we write can also be thought of as a black box, input, process, and output. We will need to declare our functions. We will need to define the functions before we can finally use the functions. So let's dive in to this black box model of building pieces of software. Abstraction allows us to manage the messiness or the complexity of programming. Procedural abstraction means that we will be organizing our solutions into smaller units of code. We are going to use the black box analogy here. A black box refers to something that we know how to use, but the way it works, we are not aware of. So a person using a program needs to know what the program does, but not how it does it. Likewise, a person using a program just needs to know how to use it, not how it works. So we are going to be building programs with functions as black boxes. The parts of our program that use the function just need to know what the function does, not the details of how it does it. The programmer will need to know what the output from that function is so that we can use it properly. It will also need to know what the inputs are to that function to be able to use it. The function declaration provides all the necessary information in order for us to use the function. It tells us what the return type will be. It tells us what will be output from the function. It tells us the name of the function. It tells us what the inputs need to be. including how many and the order of the arguments needed, as well as the types of the arguments. It provides everything we need to know in order to use the function. The function definition describes how the function does its task. The header of the function definition will exactly match the declaration. The only distinction is that it will not have an ending semicolon. The body of the function definition contains all the code that will be needed to be executed in order for the function to complete its task. Here we see that total cost will take two inputs. The first argument is an integer. The second argument is a double. Inside the function body, we will be multiplying the first argument, number of items, times the second, the price of those items, to determine the subtotal. Once we determine the subtotal, we will also calculate the tax and return the grand sum total of subtotal plus tax rate times subtotal to the calling part of the program. Note that this exactly matches the type double identified in the function header and the function declaration. When using functions, the return statement has two jobs. One, it automatically ends the function. So if you put any code after a return statement, it will never be executed. Also, when we use return, there should only be one return in a function. Good structured design tells us we should have one way into our functions and one way out of our functions. And for us, that will be the return. The second job of the return is to send a value back. This is the output we produce from our function. Now, C++ has a strict rule about returns from functions. There can only be one value returned. So our functions will only always produce 1 or 0 values. Here's a sample syntax for returning a value from a function. Now, if you think about a function as answering a question, then what we're returning is the answer. So our first example here shows a variable named answer, which we figured out in our code, and now we're returning it. The second looks similar to the total cost function, where the value is actually calculated and returned right in the return statement. The third part of functions is the using part. In order to use a function, we call it by name. So we see here that if we want to use function total cost, we use the name total cost, and we pass as inputs, also called arguments, two values: number, which must be an integer, and price, which must be a double. Total cost will execute the statements that were in its definition and send back the subtotal that was calculated corresponding to the total cost, and that will be assigned here to double variable bill. Some things to be careful about. The compiler wants you to declare your function so that it can do some checking for you. We put our declarations for all of our functions before main. These are also called prototypes. This allows the compiler to, when it finds the call to the function in code, to make sure that the parameters match the parameters listed in the prototype. It also can validate that what is being returned or output from the function makes sense in the line of code where we have put it. The compiler cannot check that you sent the correct arguments to the function. So if you mix up the order of your arguments and they're of the same type, C++ is not going to catch that logic error. So be careful when you are listing your parameters or arguments in the function that you are consistent about the ordering you use when you declare, define, and call the function. Inside the file, the function call has to be preceded by either the function's declaration or the function's definition. Now, C++ standard practice, we will be writing a declaration, also known as a prototype, that you put before the main. So all of our function declarations will be before main. So once we get to the actual code that calls the functions, there will be no problem. The compiler will know what to expect and what to look for in our function calls. Then we put the function definitions below main. So main is still prominent. We put that as our first function definition. And then all these helper functions will be defined underneath the main function. It's perfectly okay for a function to be of type bool. So a function can return any type of value. We just have to make sure that that's what we declared. Here we see an example of when a bool function would be quite useful and easier to manage and read inside a program. Take a look at those two lines of code. If you're working on a large program, which one do you think would be easier to manage? I would much rather be dealing with that first line of code than the second one. So here we see that use of black box analogy again. Hide the details of what the appropriate rate are. Keep them inside a function that, if necessary, could be changed and called by many parts of the program and only updated in one place. Let's take a look at what the code for appropriate might look like. Our prototype needs to have an output or return type of bool, the name appropriate, and the list of inputs inside the parentheses. In this case, there's only one input, the type is int, and we're going to call that rate. Then we would find the main program, and somewhere in that main program I would expect that we would make the call to function appropriate, as we see here in the if statement. Then down below, underneath main, we would have our definition for function appropriate. Notice that the header of the function looks a lot like the declaration, except we don't end it with a semicolon. Instead, it gets a set of code inside curly braces. Now this is a one-liner that just returns the truthiness of whether or not the rate was greater than or equal to 10 and less than 20, or if it was equal to 0. So that will be returning true or false, which exactly matches the data type bool and can be used in the if statement to determine whether or not it was an appropriate rate. After reading section 4.3, and reviewing the code examples, you should attempt to do the following. Write a function named sum that takes three input arguments and outputs the sum of its three inputs. Write both the prototype, or declaration, and the definition. The second one asks you to describe the call by value parameter mechanism. Let's defer that for later. We'll talk a little bit more about that in the next set of notes. The third one has you write a function named average that takes one input argument, type int, and one input argument, type double. It should return a double value that is the average of the two inputs. Write both the function declaration, also known as its prototype, and the function definition for practice. Happy C++ coding!